In this video, in this class, we reviewed a little bit about regression, and then we talked about hypothesis testing for the regression model. So let's review what regression, what we did in regression. Okay. Suppose we have a correlation distribution, a scatter plot like this, and based on the sample value, we get a correlation which is equals to 0.75, which is pretty close to 1. So we conclude that there is a correlation, a strong correlation, and of course, based on that, we can have the strengths of correlation. R square is, it's like effect size in other tests, so we can get the strength and the size of correlation. Which portion of these distributions can be explained, which portion of for example, this variable would explain this variable. So it's like 50 some percent will be explained, and that's what it is. And we and guidelines for determining the size of the correlation, strength of correlation is the magic number. There are three magic numbers. One is 0.1, another one is 0.9, and the last one is 0.25. And here are the descriptive statistics. Sum of products, and this is a mean, the mean socioeconomic status. The way it is doing it is it's like the average is 0, so it's ratio scale. So it's like a temperature. So average is 0, and so it's not like starting from 0 to so that's how socioeconomic status in this example is described. And also, of course, this is exam grade, starting from 0 to I don't know the max possible score points, but it goes up. So this is statistics. Mean socioeconomic status, socioeconomic level is minus 0.37, and mean exam grade was 83.14, and sum of square for that is this, and sum of square for that is that. And sum of product, as you recall, sum of product is this is a review of the class from a week ago. And sum of product is when there are two variables, and sum of product is you get the value minus mean, and this is also the value minus mean. You get the number, so you subtract the mean from the value, and because you sum a product, so you add up all the products. So the product for this is this times this, so it's 4, and the product for this is 2 minus mean, 6 minus mean, and the product for that is -1, and the product Okay, and you subtract the mean from that, subtract mean from that, and it's 1 and minus 1, and the product for that is minus 1. In the same way, it's 2, 2, and 4. So these are the products of each pair. So sum of products is, so there are many products. You have a product for each pair. Product of this and this. I mean, this minus mean and this minus mean. So in other words, a difference between this and the mean. Differences mean, so in other words, it's a variance. And so product. So you multiply these two numbers to get the product, the size of the variance here. And because it's sum of products, you have many products and you sum them up. So sum of these is sum of products. So that's what it is. And you get sum of products 362.25. That's which is a sum of products. Then based on that, you can calculate the slope and intercept and come up with the regression model. And a slope, it's b here. In Japanese math, it's supposed to be a, but so it's kind of confusing to some people from some different countries. But okay, so slope is sum of product divided by sum of square for x. So in this case, okay, this sum of product divided by sum of square for x. In other words, in this example, it's a socioeconomic status. Okay, so this divided by this, which is 16.98. And intercept is, you can calculate intercept manually, or you can just use this formula, and you get 89.42. So the linear regression model we get is y equals 16.98 x plus 89.42 in this example, and this line represents the model. Okay. And intercept, to review what intercept is, if you know the math, you know what it is. Intercept is the value, in this example, it's a predicted exam grade when socioeconomic status is 0. In other words, it's average, when it's average. And the slope is the increase in the predicted, slope, this is slope. This is the increase in the predicted exam value, exam grade. So it's how much this will increase when this value increases by 1 unit. Okay. So when x increases by 1, y increases by 16.98. That's what it means. The correlation between socioeconomic status and exam grade is 0.75. So the question is, what proportion of variability in exam grade is explained by SES? What proportion of the variability is not explained by SES? That's something we did in the last class too. Okay. Because r square is 0.56. This is a explanatory power of the correlation. In other words, 56% is explained. So Okay. What portion of exam grade is explained and what portion is not explained? In other words, okay, the portion that's explained is this r square, which is square of the correlation value. So 0.75 square is 0.56. So that's the portion that's explained. So this is all the value variances, sum of all the variances for exam grades. Sum of squares, all the variances for so the sum of all the variances for exam grade. In other words, y variances for y. These variances, sum of these variances, and you do square. I don't know. The mean is somewhere. It doesn't say here, but these varies, more or less from the mean. All these dots, because they're not in one line. So those variances, some of those variances, and the variances are like the value minus mean, and square that and add them up. That's a sum of square, right? So that's 11,050.49, and okay, 56% of that is explained, and in other words, 44% of that is not explained by this model. I mean, in this example, so 56, only 56% explained. So this is the total variance, in this 6,188.27 of that it's explained, and it's explainable, and this is 4,862.22 is not explainable. That's the portion that's not explained. The correlation is, and sum of square regression, sum of square residual, and those are the terms. Okay, so that's how much we've done in the last class. Just to recap.